So like our lesson plan said, we're moving up to 1-7. So we're going to look at these combination of functions. So by the end of the week, we ultimately are going to, yes? Yeah, I can do that. Yep. So combinations of functions. So ultimately by the end of the week, we're ultimately going to take like one function and be able to put it in for another function, or evaluate one function at some value and then take that value and put it in for the next. But we need to see like which x values we can use when it comes to functions, because depending about the type of function it is, sometimes we're limited onto what x values we can put in there. So if we're looking at x values, we're looking for domain. Right? Those are our x values. And just for poops and giggles, the y value is called the, starts with an R, the range. Yep, absolutely, good job. All right, so we got about 4 different examples to kind of run through. So the first one, let's say we had f of x equals x squared minus 7x. And because we're getting so good with our functions, we know that our highest degree is that 2 on our variable, right? So we know that this is going to be a quadratic. Yep, good job, right? And then we know that our quadratics make those little parabola shapes, right? The U shapes. So if we're talking about our x values, and we know this one's going to be a positive one, so it's going to look something along this line, right? And we know that that's going to keep going forever and ever and ever and ever. So our U is going to keep getting wider and wider and wider and wider and wider, right? So when it comes to our domain, we know that it's going to be like all real numbers, right? So the smallest x value we could use would be negative infinity. And what's the largest x value we would use? Infinity. So when it comes to a quadratic and it comes to our x values, we know that there's no restrictions when it comes to our x. We can put in any x value, right? We can put in a positive x, and we can put in a negative x, we can put in a 0, we can put in anything for the domain or for our x values for a quadratic. So let's find some that we have some limits to, right? So let's say we had f of x, since we're talking about some functions, equals 1 over x minus 3. Whoop, this thing. Sometimes it don't want to move, other times it wants to run. Yeah. So what do we know about fractions? There's something very specific that we know about any fraction when it comes to our denominator. What do we know about denominators and fractions? Yeah, they can never be 0, right? Because you can't have 1 rotten apple in a bucket of 0 apples, right? So our denominator can never be 0. So when we look at this one, we have to see, is there an x value that would make my denominator 0? A positive 3, right? So we know that x cannot equal a positive 3. So we want to show the domain. So we want to be able to show for what values it can be. So what's the smallest value x could be? It could be, ooh, man, those negative infinities, right? It could be negative infinity. And I can be from negative infinity all the way until I get to what number? I guess it would be this way for you guys. Right? All the way until I get to 3. And then I'm going to put a parentheses around there, right? Because remember, those parentheses means that it can get close to, but it can't equal. The brackets are the one it can equal. And then we want to combine that with some other numbers, because we just got to skip over 3, and then once we get over 3, we can keep going. So that would be a union. Remember learning about the union? And then we can go from 3 all the way until we get to positive infinity. Good so far? Ready to add a little bit more spice to it? Maybe some pumpkin spice? No. Chili powder? Cayenne? Pepper? Himalayan salt. You guys are rough again this morning. Alright, so what if we had the function f of x equals the square root of x minus 5? We like to keep it real here, right? We don't want to deal with those imaginary numbers, right? Those ghosts. That was last week. So when it comes to square roots, what do we know about square roots if we're talking about the real number system? What can our square root be? It can't be negative, right? So could it be 0? It can be 0, right? The square root of 0 is 0, but we can't be negative. So we're going to sit there and figure, I think we know that. So we know that x minus 5 has to be greater than or equal to 0, right? So we know x has to be greater than or equal to 5. So now you have to think of that smallest number that I can be. What's the can I be any negative numbers? Can I be 0? This here is telling us that my smallest number has got to be 5. Yep. Can I be 5? I can be 5, right? Because if I put in the 5, I'd get 0. So to show that I can be 5, that's when, remember, we use those brackets around the number. So my smallest number I can be is 5. What's the biggest number I can be? Infinity, right? We don't have a limit on it. So we're just going to have comma, infinity. We can never be infinity, because once we get to infinity, we can go beyond infinity, right? One more super fancy one. So let's say we have a function, and I know you guys love fractions. So let's go with a 3x plus 2 divided by x squared minus 2x minus 3. So we got a fancy little fraction up here. And what do we know about fractions? Denominators cannot equal 0, right? So we're going to look at our denominator, which was x squared minus 2x minus 3. And we know that that cannot equal 0. So we got to figure out which values of x would make that 0. Anybody got any ideas on what we could do to that quadratic to figure out which values it cannot be? Starts with an F. Can we factor it? What was that? Yep. You can either use like the quadratic formula. Yep. Or we can factor it into our little factors, right? So to get x squared, we got x and x. We're going to multiply to get a negative number. Right? When we multiply these, we get a -3. So the only way you can get a negative number is if one is positive and one is negative. So we got to multiply to get to 3, where our difference is -2. So we know we're going to have a -3 and a +1. Right? So I'd have x plus 1 technically can't equal 0, right? And x minus 3 cannot equal 0. So x cannot equal -1, and x cannot equal a +3. So we can be all the other numbers in the world except for -1 and 3. So when it comes to writing out my domain, what's the smallest x value I can be? -infinity. I'm going to run out of room. I'm going to write it below. There. So the smallest I could be was -infinity. And I get to start at -infinity, and I get to use all of the numbers until I get to -1. Right. And then I can't be -1, so then I'm going to start back up when I get just past -1. And I can be all the numbers from -1 until I get to the number 3. And then I get to start up again. Whoops, why did that turn into a V? Yeah. And then I get to start at 3, and then I get to keep going all the way until I get to +infinity. Yes.